everyone. We are hydrogen. My name is Glenn. In man. So, the purpose, the objective of our project is to use water as a supplemental fuel source. How we plan to do that? We will be generating a hydrogen generator to be implemented in any internal combustion engine. So it's a simple and economical way of going green because hydrogen is a non-toxic gas, and the less demand for the petroleum fuel source, the more hydrogen that we use. So the purpose of our design is to create a hydrogen generator that will fit in any car that's running on the road today. Our goal is to increase in gas mileage, resulting in saving money. It's a pollution-free exhaust because hydrogen combustion will result in water-like form, and increase the engine performance by running clean and lean. My colleague is going to talk a little bit more about how it works exactly.
Our design is based on the process of electrolysis. This is the process where you split the water into its mainly elements, that is two hydrogen, one oxygen. That's why the name is HHO. We name it like that. And our main goal is to create a system, a design that generates the maximum possible amount of hydrogen with the smallest possible electricity input. Building an HHO system as like getting electrolysis is easy. You get a jar with water, some electrolyte, you get a battery, two cables, you put it inside, you get electrolysis. You got HHOs coming out. But our design, our goal is to implement the right design to get the maximum power hydrogen out of this system with less energy. Remember, when we put something to any engine or a battery in the car, we're asking that engine to give us more power because we need to feed up that system that we're implementing. So at that moment, we're asking the engine to do more, to give us more power. So we have to play with these values. So what are we asking to the engine and what are we giving to the engine?
Hello everyone. Some of the advantages include increased gas mileage, decreased pollution, cleaner engine because this gas will actually keep it help it cool down, and will, hydrogen also has a faster burn speed than gasoline. Materials, stainless steel or titanium. We're probably going to use stainless steel because of the low cost. Other materials include PVC containers, copper wires. Okay, here's what our design most likely is going to look like. The outside tube, it's going to be the cathode. It carries a positive charge, while the inside tube is the anode. It carries the negative charge. The positive charge is the one that yields the O2 gas, while negative one yields oxygen. Next. Here are some pretty much the main component of our project. Prices, this is our rough estimate of what our generator is going to cost. As you can see, it's not too wide, but it'll most likely go down when we do a little more research into prices and stuff. Testing. This is a big part of our project. Is how we're going to measure the success of our thesis here. What we're going to do is we're going to drive the control car for a given distance, speed, temperature, and weight, and then we're going to use the same car with the HHO implemented and compare those results. Another test would be the gases coming out of the exhaust, and for that we have gas analyzers. These are two different types found online, and we're still searching into which one to use.
Good morning, everyone. This is our timeline. As right now, we are in the design research phase. We already done basic things such as the survey 10% report, and the senior poster, and the 25% report. For the global consideration, for environmental, we have for our hydrogen generator, we will have a positive impact on the environment, and it's also a renewable energy. For hazardous material, we're gonna have a universal warning label for our product in the manufacturing process, our product. And for multi-unit calculation, we're going to have a standard SI unit and standard English unit. for practicality, we can implement our hydrogen generator in any car, diesel, gasoline, and also we want our product to look easy to use as possible, so we can have a warning label, a universal warning label, and instruction. And as a conclusion, our generator will have much more efficiency on the car and increase power input, and also it's saving money and a positive impact on the environment. Thank you very much for the presentation.
Thank you.
All right. The very first question I want to ask was conservation of energy. Have you looked at the amount of energy it takes to generate the hydrogen in the system as compared to the amount of energy that you achieve from the hydrogen in combustion? And is there a benefit?
Well, we've done some calculations as far as the amount of amps you need to get a certain volume of gases. 60 amps for an hour will give you about 53 liters of H2 gas and 13 liters of O2. I know 60 amps is a lot to us for a car generator, alternator, but what we're trying to do is at the end get a plus. As long as we get a plus from the energy losses with the input on the gas mileage, that's how we know we're gonna be successful. But that's how
We, right now, we're not planning to create perpetual motion here. We're just trying to help a little bit the engine to getting a little bit of that current the alternating levers. That's why I said that's the biggest challenge, to create enough hydrogen to help decrease the amount of gas that we inject into the engine at that moment, to supplement a little bit with the hydrogen, that engine. And at the end, our purpose is going to be the same. Our efficiency at the end, as a closed system, our car is we're going to have same power, we're going to move the car the same way. We're not trying to get more out of the system than what is already is. We're trying to help that system, like doing the work between two.
Have you done enough math at this point, analysis, to know that you will help the system or that it'll cost you money?
Right now, we have like a prototype running in a car that is giving us about half of liter in a minute. We're running it by 15 to 20 amps. We're pulling from the car at the moment. We haven't seen that. We have no way to test it because we don't have, like a bench engine that we can put like a bench test and try and get all the information we can. So right now what we're doing is driving on a daily basis with the car, and when we implement the hydrogen, what we do is we take the oxygen sensor, we lift it, we put like an extension, so we lift it a little bit from the exhaust, and this reads the gas coming out from the engine. Tells the computer, your mix is too lean. I mean, it's too rich because it's reading no air, and it reads more gas. So it tells the computer to cool down a little bit, to cut down in gas. At this moment, hydrogen takes place, and tells the car, give the car that amount of gas that it's mixing, and that's why we play with it. Right now, that car, as soon as if we don't run it with the HHO system running, we got a check engine light. When we check the check engine light, the code given is due to leaner the mix or the catalyst of the engine, like it's reading too much of CO2. So once we pull this in, when we turn it on, this check engine goes off. Either we're reaching the right mix or we're doing a cleaner mix because the catalyst is not showing it. So that's why. Right now, that's how we test our system.
Are you guys familiar with the regular water injection systems in cars?
Yeah, we read.
I used to be a hot rodder, so
I know we got a topic.
I'm familiar with nitrous oxide and all that stuff. So I know in the old days you used to just put without splitting it into hydrogen and oxygen, you just put just regular water.
Yeah, like methanol injection.
And methanol injection.
Yeah, I'm familiar with methanol injection.
So,
but our system is different because it'll be like a loop We're basically pulling currents off of the alternator of the car and then splitting it, hydrogen, back into the car using it. So it's not like a methanol injection where it just inject, water into the engine and making the piston cleaner and stuff like that. It's different, but it's almost like the same concept, but hydrogen will increase fuel mileage. That's the better part about that than a water source.
Excuse me, can you guys talk a little bit about your design choices that you're going to make within the actual generator? So you mentioned you're going to try to optimize that. Can you talk about that?
So right now, the prototype we have is just 17 plates, one after the other one. The water goes through there, and then you have the electrons moving around. But this gives us a lot of since we're using potassium as an electrolyte, a lot of residual of the potassium stays between the plates, and you have to be cleaning this after a month or 2 months running it. You see the decrease of the output of hydrogen, of the gas. So what we're trying to implement is our design is going to be in immersion water, and we're going to have a pump this, like checking the level of the water and pumping only water to the system. Electrolyte, we don't have to add more once we get the right mix, because it stays. What it goes out is just water, hydrogen and oxygen.
Our research has shown that the circular tubes will probably be the better choice.
Got a quick question. Maybe I'm missing the point here, but how are you connecting it to the engine? How is that water being pushed through those pipes? Is it through the water pump, or how?
No, it's when we get outside our system, it's gonna be like a plug-in system. We connect that system to a battery, positive and negative, and then what we got is just a hose, put in gas, and we're gonna plan it to put it in the intake of the car. And with the air manifold, when the air comes in, we're gonna put some hydrogen too. So
Into the intake of the engine.
when we have the emission, at that moment, it's gonna get hydrogen, oxygen, and the oxygen comes out of the car.
Okay. I wasn't sure how that was working.
It's a water tank.
Okay.
Yeah, we're not injecting water into it, we're injecting hydrogen.
Hydrogen, right.
Now, in the new car systems where everything's computer controlled, where it'll control your mixture and all that, will that have any effect on that?
It would have been nice if we can create like a system, like a model that is capable to control our mix, because we can control, tell the engine how much gas we need at this speed, how much gas.
Right, because the engine could compensate itself and overturn
That's what
what
we're
you're
using
doing.
right now, oxygen sensor. That's pretty much the sensor they use to compensate the mix inside the engine.
Right.
So that's why we lift it and we try like that. That's the one way to try
Okay.
it.
Actually, I have a backup question. Besides the oxygen sensor, what other sensors are you looking to use from the engine? Because there's many sensors on the engine nowadays. Have you thought about that? Take advantage of what's available.
Maybe the mouth flow sensor that we can read from there, but like I said, we're not planning to do too much with the electronics with the car, because that's gonna be we're mechanical engineer. We have to be more background about the circuits and what is all the prepare like a system that controls either mouth flow getting in and the oxygen sensor what is getting out outside here.
But we will be using a pressure sensor, so that will tell us like how much pressure is in the line to make sure that we don't overdo the pressure that's inside the line, or we have enough pressure that can go inside the engine, and we will monitor it with the little gauge inside the car.
About division of labor, how equitable is work been divided amongst you all, and do you foresee the need for additional outside resources to bring in all of the intelligence and knowledge and expertise that you need to get this thing working?
Well, we have planned to just do research, individual, on our private research to see how, the system can work, and trial and error is the main key to this project. We will be creating, we will be putting out this amount of amp, and this amount of water, this amount of pressure. Will that increase this amount of, gas savings? And then we will continue trying, and, we will find our best result that way. Better than, using sources for what other people say. I think that trial and error of our own test with us.
So that's the process, but how about the division of
How about the
labor?
division? Pretty much, we divide it into, as, design, mathematical testing, theoretical testing. Basically,
What you're trying to ask is how we divide it between us, right? Like, every time we do something, we just sit down and do it together. We don't really split the job between us, it's, let's do it. And that's the way we've been doing it until now, and that's the way we're going to do it. Four heads at the same time, we got more ideas, and it's like, if we have any contradiction between us, we solve it right there, and then we come out with what we want. We don't have to wait.
It's total teamwork.
Yes, totally.
All right, thank you.
Thank you very much.
One real quick statement. The output of fuel efficiency is a pretty hard output to be able to measure. Unfortunately, it is so big, so much goes into creating it, that you end up in a situation where you may have an impact here, you may have a success here, but you may not be able to measure it. I would suggest that you at least look at another output so that you've got an opportunity to measure success another way, in case it turns out that you can't demonstrate fuel efficiency. It may be that your scale's not right, maybe you need to be bigger, maybe you need to be, things that you won't have an opportunity to do, but you still could have a success with the project if you had another output.
I want to add that with the prototype we have, when we run it with the HHO system, we get like, we can say roughly between 15 miles to 20 miles increase per tank.
Already demonstrated.
Yeah, when we have the prototype in the car, that's what it gave us. Like, driving on a daily basis. Yeah, that's what you said. It's a lot of things to take into account because it's the way you drive. You drive in the highway, you drive in the city, the way you like to drive,
You gotta test it in a track. So just simply a whole tank in the track.
The nice way shouldn't be like a plane stage to have an engine. We don't have we can afford that. Put it there to get all the sensors, to hook up the computer and read the mix, read everything. We don't really have that, so we have to go with what we have.
So I mean, that just highlights the point that when you do your testing, you're going to have to standardize everything.
Just a quick comment.
Okay.
As you write your report, you need to be very careful. You need to proofread it very carefully. There's some errors in the report, and so you need to be very careful. Actually, you have your advisor name spelled wrong in the report, so be very careful. You need read it very carefully.
We try to fix that.
All right, thank you.
Yeah, I don't think he's too happy.
We got to start behind that.
Okay, thank you very much.